Okay, welcome to your answers for section 5, no, 11.3 in your grade 8 textbook. It says Joe takes one marble from the first bag and Ron takes one marble from the second. It says use multiplication. So we're no longer using a table. You could if you wanted to, but use multiplication to calculate the total number of possible outcomes. So in the last section, we realized that if you take the possible outcomes in the first event, multiply it by the possible outcomes in the second event, you get the total number of combinations of those events from occurring. So in this case, if there's 4 marbles in the first and 5 marbles in the second, there's 20 different combinations. And if you wanted to, you could do blue, 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 green, red, 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 yellow, yellow, which is what you would have done in grade 7. And you would see that there are indeed 20 possible outcomes, right? But the second thing says B, what is the probability of blue, red being drawn? So if I look at B, the probability of blue, red, if I look at my table that I did over here, the probability of blue, red, I have a blue, red, oh, it has to be in that order, isn't it? So blue, red, 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 blue, red. So in my table, I see clearly that there are 9 chances out of 20 for drawing a blue-red. But I'm not supposed to do this method here. It says just use multiplication. So if I look at the probability of blue, it is 3 chances out of 4 in this bag that I will draw blue. In the second bag that I will draw red, it is 3 chances out of 5. So if I take those probabilities and not add them, but multiply them, I get 9 out of 20, which is the exact same probability I got over here by examining my table. So rather than do the table each time, the grade 8 connection is that you will learn to multiply the individual probabilities, in this case bag 1 and bag 2. What we're looking for, the favorable outcome was blue in the top, favorable outcome in the second one was red in the top, and you'll still get your probability, which I can change to a percent as being 45%. The second question says a forecaster predicts that the chance of rain today is 75% in Victoria and 20% in Calgary. This is kind of neat because 75%, you could write it one of two ways. You could write it as 75%. You could write it as 75%. I'm going to do it both ways. So for event 1 in Victoria, the probability is 75%. Now you can keep it, Mr. Ballum, as 75 out of 100, or you could do what with it? Reduce it down to lowest terms. I'm going to reduce it down to lowest terms just because it's easier. So in Calgary, the probability was 20%. In lowest terms, that's 1/5. So I know if I take those two and multiply them together, I'll get 3 out of 20, which as a percent, as a decimal is this, and as a percent is this. Now what I want to show you up here is I'm going to do it straight up as decimals, not as fractions. If I convert a fraction to a percent or a percent to a decimal, they're all the same thing. But if I see this as being 75% and this is being 20% and this being 3/4 and this being 1/5, no matter which way I do it, I'm going to get the same answer. So if I take a calculator and multiply my 75% probability in the first event, multiply it by the 20% probability in the second event, I still get that same answer, 15% probability. Right? So I don't have to think of it as a fraction. I can actually solve it using percentages. It's still 15%. Question 5 says, what's the probability of red and then blue if one marble is randomly selected from each bag? So the probability of red from this, there are 1, 2, 3, 4, 5, 6, 7 marbles in this bag, 5 of which are red. So favorable outcomes from the draw to get my red marble is 5 chances out of 7. In the second bag for the blue, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles, and 6 of them are blue. So if I multiply those two together, I get 30 out of 70, which is my answer as a fraction. I get, if I take 30 divided by 70, I get 0.428571. 0.428, roughly, approximately, or approximately 42.8% or 42.9% or whatever it happened to be. Okay, that's the probability of that happening. Okay? Any questions on that? Does that make sense? The key is individual probability from the first event, individual probability from the second event, multiplying them together gets you the combined probability of those two events happening together, right? Question 16 says a deck of 52 playing cards, a card is drawn at random. So what is the probability of drawing a 4 on the first event, 7 on the second event? So for the first draw, drawing that 4, there are 52 cards. 4 of those 52 cards are 4s. Then on the second draw, I'm putting that 4 back in the deck. I have 4 cards out of 52, which are 7s. Multiply those together, I get 16 chances out of 2,702. Is that right? Is that what 52 times 52 is? Yeah. 04. There. So if I take my calculator, 16 chances out of 2704 is 0.0059, which we remember because of the last chapter. If I think about that as a decimal, it's 59 ten-thousandths, which is 0.59 hundredths, which as a percent is 0.59%. Just a little bit more than half a percent chance. You have a 99.41% chance. Oh, sorry, I got that in the wrong space. A 99.41% chance that you will not draw a 4 on your first draw and then a 7 on your second draw. So the probability of that happening is fairly low. In your second question, what's the probability of a 4 on your first draw and not drawing a 4 on your second draw? So for the first draw, the probability of drawing a 4 is the same as it was in the last question, 4 to 52. But your probability of not drawing a 4, how many cards in the deck are not a 4? 48 of them. Okay? So some people make the mistake of doing this, right? Some people make that mistake, and that's not what you do. You don't add them together, because if you added them together, you get what? 52 out of 52, and your percent would be 100%. But the job is to multiply them together. 48 times 4 is 196. No, it's not. It's 192. 192. 52 times 52, we just did it. It's 2704. So the probability of drawing a 4 on your first and then not a 4 on your second would be that as a fraction. But more importantly, as a decimal, is 0.071, which is 71 thousandths, which is 7.1 hundredths, which is 7.1% approximately. Okay? Does that make sense to people? Yeah? So significantly greater than the first event of drawing a 4 on the first and 7 on the second. Your last event is what's the probability of drawing a 4 on the first and a number less than 4 on your second. So our first event, again, doesn't change. Drawing that 4 on your first one is still 4 chances out of 52. Drawing a number less than 4, well, all of your 3s, all of your 2s, and all of your aces would be only cards less, which would be 12 chances out of 52. The product of those is 48 out of 2704, which if I take my 48 divided by 2704, the probability of that happening is 0.0177, which is approximately 1.8% approximately. Okay, any questions on 16? Is that the last question? 17 too? Okay. So question 17 says, oh yes, the probability experiment consists of these 3 independent events. So there's an independent event A, which is right here. independent B, which is right here, and independent C, which we don't know. But we know the probability of all three occurring is this. So here's what we're going to do. We're going to set up like this. So event 1 is right here. Event 1. Or we'll call it A, sorry. It's A. This is A. B is 3 chances out of 7. And it could be anything. It could be spinning a spinner, rolling a dice. Who knows what it is. C, we don't know. So I'm just going to leave a box over a box. But I know the probability of all three of these happening together has a theoretical probability of 9 chances out of 70. Okay? So now all I have to do is just use a little bit of basic common sense. 1 multiplied by 3 multiplied by what equals 9? 3. So the number that goes up here has to be 3, correct? 1 times 3 is 3. 3 times 3 is 9. So whatever this event was, I had 3 chances out of whatever it was to get 9. 2 times 7 is 14. 14 times 5 is 70. So therefore, the probability of C as a fraction, C had to be 3 chances out of 5, or 0.6, or a 60% chance that event C had to happen in order for the theoretical probability of all three events happening being 9 chances out of 70. So the answer for this question is event C had to be a 60% chance of occurring. Okay? And if I want to put this into a weather perspective like our weather was, in Halifax, the chance of raining was 50%. In Charlottetown, the chance of raining was 41.2875%, or whatever that works out to be. And in Fredericton, the chance of raining was 60%. What's the probability that it will rain in all three cities on the same day? It would be 9 chances out of 70, which would be probably 10. I don't even know what that is. What is 9 chances out of 70? 18%? No, 13%.